be talking about polynomials today. A monomial, we're talking about polynomials today. A monomial, I'm going to zoom in so that way you can see better. A monomial is just a set of numbers or variables that are being multiplied by each other. So technically x to the fourth power is just x times x times x times x. So it's just multiplication, right? When you're talking about negative exponents, addition or subtraction, and division, that no longer can it be a monomial, okay? If you're talking about the degree of a monomial, all you do is add up all of the exponents of the variables. A constant is like number 5. It's just a number. Has degree 0 because there's 0 variables, right? That sort of makes sense. If the degree is the number of the variables that you have, then a constant would have degree 0. So let's go through just a few examples and talk about the degree of each monomial. This should cruise by, right? If we're talking about this first example, finding the degree of these monomials, what should my degree be? That pen does not work, does it? What should my degree be here? I think it should be what should my degree be? I can wait all day. Should be easy. Yes, beautiful. Thank you. What about for problem B? This should be quick. What's my degree? Does that help? I have 1E and 1D, so my degree is 2. And then this last one, how many variables do I have? Yeah. So whenever you have no variables, your degree is 0. Does that make sense? It does help if you put an imaginary 1 next to your variables, if you're counting the degree. I think it helps. Okay, moving on to our next definitions. Let me zoom out a little bit because this seems a bit extreme. So a polynomial is just a whole bunch of monomials being added or subtracted together, right? So we talked about what a monomial is. It's just a product of variables and numbers. A polynomial is a whole bunch of those being added together. The degree of a polynomial, though, is the degree of the term with the biggest degree. So you're going to have a whole bunch of different monomials, and you have to pick the degree of the biggest one as the degree of your polynomial. Right? That's going to be like a default. It's the biggest one. So I will give you a second to copy that down. Let's turn the page. All of these examples are polynomials. So if you look, I have 11 times x 7 times. That would be a monomial. This is also a monomial. What is the degree of this first term right here? I have 7 x's, good, and the degree of this one is 3, right? So the degree of my polynomial is 7. You just pick the biggest one. Does that make sense? You find the degree of each term, and you pick the biggest one, right? So what's the degree here? I have 1x here, and then the degree here is 0, right? So the degree of this polynomial is 1. Does that sort of make sense? Okay. We can go through, let's just do one more here, this example. This is one term. My degree should be what? I got 3 here. In this case, in the second term, I have 4 z's, and then this last term, my degree is 0, right? So, overall, my degree should be 4, right? So this polynomial is not written the correct way. There's this thing called standard form, where you're supposed to write your polynomial in order by highest degree to lowest. So if I were to rearrange this to put it in standard form, remember, that would be highest degree to lowest. So I would have to have 1/2 z to the 4th written first, then the 1/3 w squared z, then the 5, right? So every polynomial ever should always be written in standard form. There are big reasons for that, both in this class we'll talk about later, as well as in Algebra 2. It's going to make a big difference. So make sure that if something's not in order by degree, then you should put it in order, okay? All right, let us be on our way to the next example. We just talked about this, right? The standard form. So once again, greatest degree to least degree. So if we put things in standard form, you could probably just add that little definition underneath what we wrote for the last example, right? Just say highest degree to lowest. This idea of a leading coefficient, though, it is extremely important when you're talking about the orientation of a graph. It tells you if things open up or down. It tells you if things are being stretched or compressed. We'll get to all of those things in Algebra 2, but for now, being able to identify the leading coefficient is really important. So in identifying the leading coefficient, you need to make sure you're in standard form first, and it's the number before the first term. So it's basically, I like to think about it as the number that leads you off into the entire polynomial, right? What's the first number that you see? So if I were to put this last example back, up here maybe, can I fit it? Yes. So up at the top, I put that equation, or that polynomial in standard form. What would my leading coefficient be? That would be the degree, right? 4 is the degree. What's the number that leads you off? What's the very first thing you would read? 1/2. There you go. My leading coefficient here would be 1/2. So maybe to this example, you want to add that the leading coefficient is 1/2. And hopefully you can see the importance of putting this in standard form first, because if you didn't, you would have the wrong leading coefficient of 1/3, right? You can feel free to shorten leading coefficient to LC as well instead of writing out those words. It's a lot of words. As long as I know what you mean, we're good. All right, let's move on to some examples. Once again, putting the polynomials in standard form, it means you have to put them in order from highest degree to lowest. So what should my first term be? Ah, good. Make sure you're taking the sign in front of it first, right? And then we have, what is it, a positive 4x squared, that would be the next degree. And then the 6x, and then the 9, whoops. So this is in standard form. What's my degree? My degree is the biggest degree that I see, which is 5. And my leading coefficient is -7. Do you guys feel like you could do this on your own? I really don't think today's lesson is like horrible, but it is, you have to pay close attention to details, right? So common mistakes are people forgetting to take the negative with the 7, or oops, I didn't even see the degree 5 here, right? So just tiny little things. But let's keep moving. I think you guys can put things in standard form, find the degree, find the leading coefficient. Last thing that we need to do, and yes, you do need to copy this down, is talk about the degree and give it a name, and then the number of terms and give it a name. So this table, yes, you do need to copy down. I'm going to give you guys. So once again, these little stems for the number of terms should help you a little bit. And then same thing with some of these terms, like cubic, 3-dimensional, 3, a cube is 3-dimensional. For 4, split it into quarters, so quartic. 5, quintuplets, or quince. In math is like factor of 5. I don't know in Spanish, but anyway, are we all set with the table? I think we are. Let's go through and talk about these examples here. So for example A, first things first, check to make sure you're in standard form. In this case, we are. We're in order from highest degree to lowest. So it says, what's our degree? Our degree in this case is 3. So what's the name that goes with degree 3? Look, cubic. Yep. So that's one word I need. How many terms do I see? How many different pieces? I see 2 separate pieces. So this is a cubic. What's the other word? Binomial. Bless you. That sort of makes sense. So this next one, our degree is 6. And there really isn't a word once you get past 5, so you're just going to call this 6th degree. And then how many terms do I see? If I have 4 terms, oops. So if I have 4 terms, this is a polynomial. Do you guys see how you're using the degree and number of terms to pick 2 words from those tables? I just want to go over this last one. I don't know why people get confused about like examples like this. What's our degree? So this is linear, right? And then number of terms is, so this is just a monomial, right? Is this one going to be linear over here, problem E? No, what's my degree? 0, because I have no variables, so this would be a constant monomial, right? But yeah, I think we're good. I